Welcome to our video on electromagnetic compatibility (EMC) in electronics. Now, let's meet the members. DAMIA NURINSYIRAH binti Muhammad ADNAN, Natasha Haneem binti YAHYA, ADRIANA SAFIYAH binti Muhammad HAZLI, and last but not least, AFIQAH binti Muhammad RIZAL. In this video, we will be talking about 7 agendas. Number 1, Introduction to the topic and its significance. Number 2, Explanation of relevance electricity and magnetism concept. Number 3, Detailed exploration of our chosen application or technology. Number 4, Examples of real-world information. Number 5, Potential benefits and challenges. Number 6, Future developments and innovations. And lastly, number 7, conclusion summarizing key takeaways.
First, let's learn what is the meaning of EMC. EMC is the electromagnetic compatibility, which is the ability of electrical and electronic equipment to operate without interfering with each other. All such equipment that emits electrical energy, some may emit energy that enable them to interact and interfere with other equipment. AMC has a regulations which ensure the device does not interfere with other devices or radio and telecommunication when used as intended. AMC regulations require the device to meet specific standards to ensure they can function safely and reliably in other electromagnetic environments. Here are some examples of AMC regulations. First is AMC Directive 2014/30/EU, which limits the electromagnetic emissions from equipment and governs the immunity of equipment to interference. The second one is Great Britain's Electromagnetic Compatibility Regulations 2016, which allows the manufacturers to affix the UKCA marking or the CE marking to the equipment placed on the GB market. Some of the testing methods used in EMC is conducted emissions, which test the emissions through cables. Second one is radiated emissions, which test the strength of electromagnetic fields produced by an electrical product. The third one is electromagnetic field testing, which measure the amount of electric, magnetic, and electromagnetic exposure. Next, let's look at the significance of EMC. First, it will boost reliability. AMC testing shows that a product is compliant with established requirements and regulations. Second, EMC ensures that the equipment is designed to not generate electromagnetic disturbance and be immune to electromagnetic disturbance from other sources. The third one, EMC testing is necessary to meet regulatory requirements, improve product performance, and reduce the risk of costly non-compliance. Next, AMC also helps prevent unwanted effects that can cause physical damage to equipment. And the last one, the EMC will help reduce service costs. Sophisticated EMC testing equipment can provide long-term service and manufacturing benefits for the product.
Now, we will continue to the next agenda, which is relevance of electricity and magnetism concept. The relevance of electricity is heating. It is to cook food and warm people during winter. It is because electricity will produce heat that could help to increase body temperature and to cook food. Secondly, it is for industrial processes. Machinery in factory continue to work for 24 hours, thus it need uninterrupted electricity. Thirdly, it is for lighting. Light are one of the essential things in our life. It helps us to do our work during day and night. That is why lighting is to make sure people could work during the night. And finally, electricity are used for powering appliances. Modern appliances require a lot of electricity. Next, we will talk about relevance of magnetism. First, magnetism is used for medical appliances. Machines such as MRI uses magnets to scan human body. Secondly, magnetism is also used for electric devices. It is used by television, radios, and microwave. Thirdly, magnet is used for magnetic separation. It is used to sort and purify materials that have metal in them. And lastly, magnet is used for recycling. It is used during recycling process. Finally, we will talk about relevance of electricity and magnetism concept. Electric motor uses electricity and magnet to create force to help it to move. Secondly, magnetism is also used for industrial work. Mechanical energy is converted into electricity with the use of magnets in electric generators. Thirdly, electromagnetic wave and fields. Electricity and magnetism are both involved in electromagnetic field and wave, which include radio wave, microwave, visible light, X-ray, and gamma ray. Finally, electricity and magnetism concepts are also used in air navigation. Airlines ask passengers to turn off devices that use electricity during takeoff and landing because they can interfere with the air navigation. Our next agenda is detailed exploration of EMC in electronic. EMC in electronic is the ability of electronic and electrical equipment to function properly without interfering with other devices in its vicinity. EMC ensures that devices are set up to operate satisfactorily in their intended electromagnetic environment. How does EMC works in detail? It limits electromagnetic energy. It limits the amount of electromagnetic energy that equipment emits, receive, or propagate. Secondly, it prevents interference. Prevent equipment from emitting energy that could interfere with other equipment. Finally, EMC protects from interference. Protects equipment from receiving energy that could cause it to malfunction. Finally, the uses of EMC in electronic. Firstly, it is for safety. It ensures that electronic devices are safe to use, especially in critical applications like emergency communication and aircraft navigation. Secondly, it is used for performance. Electronic devices are able to perform as intended without being adversely affected by other devices. And finally, it is for reliability. It is to ensure that electric devices are reliable and can function safely and reliably in electromagnetic environment.
Next, we go through to the examples of real-world implementation. EMC in electronics ensures that devices can operate without interfering with or being affected by EMI. There's a lot of examples of real-world implementation such as consumer electronics, telecommunications, healthcare, and automotive industry. For consumer electronics, smartphones are designed with shielding and filtering techniques to prevent interference from Wi-Fi, Bluetooth, and cellular signals. Meanwhile, for laptops and tablets, incorporate EMC compliant circuit designs to avoid interference with nearby wireless devices. Then for healthcare, MRI machines called shielding prevents external EMI from distorting the magnetic field used for imaging. Meanwhile, hospital equipment devices like ventilators and infusion pumps are EMC compliant to prevent interference in critical care settings. Next, for telecommunication, 5G base stations, EMC measures minimize interference with existing 4G or Wi-Fi networks. Wi-Fi routers, shielding and filtering ensure stable performance in environments with multiple devices. Finally, automotive industry, electric vehicles, advanced shielding prevents EMI between the high voltage battery systems, inverters, and sensors. Then let's see the potential benefits and challenges of the EMC in electronics. EMC benefits in reducing the risk of malfunction in critical systems like medical devices or automotive safety systems and preventing the excessive electromagnetic emissions that could harm users or sensitive equipment. But there are some challenges of EMC too. Devices may encounter diverse electromagnetic environments, for example, urban areas, industrial zones, and making universal EMC compliance difficult. EMC countermeasures like filters and shielding can reduce system efficiency or alter performance.
Now, let's look at future developments and innovations. Electromagnetic compatibility (EMC) ensures electronic devices function without causing or being affected by electromagnetic interference (EMI). As technology advances, improving EMC is essential for the smooth operation of interconnected devices. Future developments will focus on new advanced shielding methods to enhance performance and improve filtering mechanisms to minimize interference. Advanced materials for EMI shielding. Traditionally, EMI shielding, like metals, are effective, but they can be heavy, bulky, and inefficient. In the future, lighter, more effective material will be developed to provide better shielding against electromagnetic waves. These materials will be designed to absorb or reflect EMI more efficiently while also being lighter and cost-efficient. For example, researchers are working on materials such as carbon nanotubes and graphene-based composites, which have exceptional electrical conductivity and flexibility, making them ideal for future EMI shielding. Next, advanced EMI filtering and active cancellation technique. As wireless communication systems like 5G become more widespread, managing interference becomes more critical. Future innovations in EMC will focus on integrating advanced filtering technologies that can efficiently suppress unwanted frequencies. Active EMI cancellation techniques involve electronic circuits that generate counteracting signals to eliminate interference in real time. This approach is particularly useful in high EMI environments such as medical equipment or industrial applications where traditional passive shielding may not be sufficient. For example, in autonomous vehicles, which rely on numerous sensors like radar and cameras, EMI could disrupt the performance of these crucial systems. Active EMI cancellation circuit could be incorporated into these vehicles to ensure that electromagnetic interference from these vehicles' own electronics or from external sources does not compromise sensors' performance. Lastly, adaptive EMC systems for dynamic environments. Future EMC solutions will likely include adaptive systems that can automatically adjust to changing electromagnetic environments. For example, a device could use real-time sensing to detect EMI levels in its surroundings and adjust its shielding, filtering, or operational modes. This would be particularly useful in environments with fluctuating interference, such as aircraft or satellite systems, where electromagnetic environments vary based on location, altitude, and external factors. By adapting to these conditions, devices can operate more reliably and reduce the risk of malfunction. For example, satellite communication systems could use adaptive EMI filtering technologies to detect and reduce interference from ground-based communication system or other satellites. This would ensure that satellite signals remain clear and uninterrupted.
As for the conclusion for this video, AMC in electronics plays an important role in ensuring the electronics produced for the consumers in good quality and safe. Besides that, AMC is proven to benefit a lot of industries around the world, such as in healthcare, telecommunication, electronics, and automotive industry. Despite that, researchers and scientists are still exploring and expanding the uses of AMC for other industry. For example, the advanced materials for EMI shielding, advanced EMI filtering, and active cancellation techniques, adaptive AMC system for dynamic environments. This just shows the big impact of AMC had towards electronics industry and how much AMC are able to benefit the electronic industry and also the consumers.